It gives you a velocity equation. This one was pretty straightforward as far as what I had. I didn't have a lot of gobbledygook there defining the problem. It was just a velocity equation. Standard particle motion, initial position when t equals 0 is 7. All right, find the acceleration at 5.1. Straight in your calculator. Straight in deriv at 5.1. This was 1 point. It was 6.492. You could have put 6.491 or 6.492. You didn't need to interpret anything. You didn't need units. You didn't need anything. Just the answer. 1 point. Boom. Done. Okay. Part B. Joel.
How did you find it on your calculator? You put it in your calculator and you put it in light with light with what?
What you talking about?
Yeah, you grab that one and you grab light with 1 and 2.
Oh, are y'all talking about B?
That's what those
are. Oh, I'm sorry. All right, B. So B asks you for the speed. It doesn't ask you, some of y'all found the velocity and the acceleration and talked about signs at both of them. It's not saying is the speed increasing or decreasing. What is the speed? Well, how do you find speed? Absolute value of velocity. So you want to know where that equals 1. If you did that, you got a point. Even if you solved nothing, if you wrote absolute value of velocity equals 1, well, I know, but listen, you got to show your work because some of you aren't showing, and I know that's what you did, and you didn't get a point for doing that, but I know that's what you did. Speed is absolute value of velocity. Right, so it equals 1. I graphed this. I think this is what you were asking, Logan, why it was explaining. You graphed this, and you graphed that. Is that what you did and found the intersection? What I did also. Twice. Did you do absolute value of velocity or just velocity? If you did just velocity, it only gave you one of the answers. If you did absolute value, it gave you both. So then asked if the speed is yes. Yes. All right, so 2 points for the two solutions were 0.7718 and 1.401. You got 1 point for this. You got another point for both of those. Part C. Find the position of the particle at time 4. Is it moving away from or towards? So here's what I thought through on this one. And a lot of you missed this one. A lot of you, I was very proud of you for remembering to add in that initial condition. So the position at 4 is going to be the integral from 0 to 4 of velocity, but I have to add in that initial position. Now, if you had this integral, you got a point. If you added the initial condition, you got a point. Okay, give yourself a point.
Did you have a D2?
Oh, I didn't have a D2.
It might be. You did the integral? Did you write the integral? But it's divided by 10t cubed plus 3. Did you just do the numerator? How'd you do that? How did you do that? You can't just do the integral of the antiderivative at the top and the antiderivative at the bottom, because that would be like a quotient rule kind of thing. With calculator, it's more about showing your setup and using your calculator to do it than it is actually doing. So if you get bogged down in trying to like work a problem out, you're probably going a little bit sideways. I think I will hook my camera up because it's going to take me too long to work. This gave you, if you used your calculator. This gives you 6.712. That was another point for the answer. The hardest part, which was is it moving away from or towards the origin? Yeah. You get an answer point. Did I not give it to you? Adjust if I made a mistake, because I was definitely grading fast. I had to leave at 2 on Friday, and I had to get y'all's graded before I left, so I. All right. Here's what I did. So at t equals 4, I started thinking about a number line because I knew he started at 7, right? And the velocity is positive and at 6.72, so he's moving, if he's here and the velocity is positive, that means he's moving this way, so it's got to be away from the origin. So they said that position is positive, velocity is positive, which means that it's moving away from the origin at time 4. So the movement with the justification was only 1 point. So this was a 4-pointer. You got 1, 2, 3, and then all of this was just 1, which is crazy.
Where's the origin?
Origin is just this 0, yeah. But it didn't start at the origin. It started at 7, right? And then at 4, it was at 6.72, so it had moved this way, but then it starts moving this way. Oh, yeah. Sorry. Don't please check over and make sure I gave you all the points you were supposed to get, because I was grading very, very, very quick. Like, I usually take a little more time with y'all, but I knew I had to get through. All right, Part D, bless you, whoever that was. Part D. What? What's my time, though? There's a definite lag here. All right, during the time interval from 0 to 4, does the particle return to its initial condition? Or initial position? This one was harder for me, I thought, because I really had to reason through it. And so you can see where I went through to see, what did I do? At 4, it was at 6.712. So at any point in time, does it hit 7? So I knew that at 1 second, I found every place it was 0, the velocity. So I knew I moved to the right, then to the left, then to the right again. And so because it starts at 7 and it goes right until it hits 9.404, I used my calculator. I used my calculator to find the position at, right here, S of 1. Because when I finally figured it out, I was like, because I had to sit there and think about it a second. And I did my little one, so I was like, yes. So it moved to the left, and then it moved to the right. So if at 1 second it was at 9.404, and then you know from your previous that it was at 6.712, then you know it had to cross over. That's your intermediate value theorem. This one was 2 points. This one was the one I think that I said I felt like was kind of hard to get. You got LITRES. It can go either way. That's the way it was in the problem, I think.
No, it's not.
Oh. I'm pretty sure yes. Look it up. Yeah, see? Okay, so I found position at 1. Right. Okay, so what I did first was I said, where is velocity 0? I already have velocity in my Y1 on my calculator. So I went in to see where is it 0. So where is it changing direction? It changes directions at 1 and 3.596. I calculated those zeros on velocity. Are y'all following me? Where velocity equals 0 is where my position switches, right? If the sign of velocity changes, then my particle changes direction. So these are the only two places it was 0. Here, it started moving right, then it started moving left, then it started. So I needed to know how far it moved left and how far it moved right. So what I did was I found the position at 1, same way I did in part C. Then the position I know at 4 is 6.712. So if you think about it, if he started at 7 and then he went to 9 and then he went to 6, he had to cross over 7 to get there, right? There's no other way to get from 6 to 9 without crossing over 7. And that's that intermediate value theorem. So 1 point for the answer with reason. 1 point, it says for sandwiching the initial position. Okay. Did you say IVT? Intermediate value theorem. Yeah.
It was one for looking between values, and then it was another for. So then I get 1 point. Stella? I just didn't say I did.
Okay. All right, question 2.
Sure, give yourself.
Question 2. I was surprised about this with some of y'all because some of these were a little bit easier than what you made them. I think sometimes y'all think that it's harder than what it is, and you just look at it, you get intimidated by it, and you go, "Man, I can't do that." But you can. It's just getting a handle on what they're asking. All right, remember this is calculator, okay? That's the key is if you don't have to use your calculator, Logan, then make the real exam hard this year. And we've got to meet with Miss Chickering on April the 1st in the lecture hall so she can show you how the exam is going to be. I know. But this part will be on your computer, and then you will have a booklet that you write the answer. So it's going to be a little bit harder because you won't have all this that you can highlight and underline and it's a hybrid. No, just a booklet and a computer. And then the multiple choice is straight online. I know.
Hey, what do we put at work?
Yeah. All right. Listen, and I did tell y'all it's at the old ATEC, right? It's not at WTC this year. East Camden.
Are you gonna be there?
Okay. It's gonna be at ATEC, the old ATEC. It's not central anymore. Out down like off of Red Fox Road, Camden by the airport, by CMA and the airport and all. All right. How much water will be in tank A at time? And you have to understand that A is given as a rate. A of T is a rate. So to find the amount, I need to integrate. So I'm integrating from 0 to 4.5, and that is for A. And that is, again, strictly on your calculator, you have an equation. So this one was actually 2 points. You got 1 point for setting up your integral, which means you need the dt, and then 1 point for the answer. So that was a 2-pointer. Part B, during the time from 0 to K, water flows into B at a constant rate of 20.5 liters per hour. Remember, again, these are rates. Yes. No, because it says.
No, the one where DFT equals 20.5.
No, but you want to know during the time water flows into B at a constant rate. Yeah, but I had to know, where does this happen? This is the place where they intersect.
No, I know. No, go back. Still no. Way on the left.
I know. Because in order to find this K value, I had to set A of t equal to 20.5. Okay, so listen. The 3 for part B. Okay, so look, this one, it says from 0 to K. So look up at your graph. From 0 to K, K is my intersection point. That was defined earlier, okay? So if K is the intersection point, then that's you exactly. You plug it in your calculator. Where is A 20.5? Because that's going to tell me the T value there, which is going to give me my bounds. Okay? You got, and then, yes, and then this, because it's top minus bottom, I always try to write y'all little notes. I did a little note over here. This means B of t, the amount in B of t goes from 0 to K, and it's just 20.5 because it's a constant rate. So here, again, this is in your calculator. You're going from 0 to 0.892 that you found here, and you get 10.599 liters. Now, you got 1 point just for understanding that you had to set A of t equal to 20.5. No, I don't know why they make you write that, but they did.
No, you did the integral right.
Well, but you also, so 1 point here, 1 point for this integral where you did 20.5 minus A of t. That's a point. And then the answer's a point. So it's 3 points. Yes. That's exactly what you're doing. It's a wordy way of saying that you understand that where they intersect is where they equal, and then you're finding the area top minus bottom. 1 point for this, A of t equals 20.5. Here, I'll show you. A of k equals 20.5 is 1, the integral is 1, and the answer is 1.
So we don't get a point for finding that upper bound, that 0.9.
You would think you would, but you don't.
Because I did that.
But if you used it in your integral, you do. All right.
It's 831.
Area bounded by the graphs of y equals A of t and y equals B of t between these two values is 14.470. How much water is in tank B? So what I did, that they gave that to you. It's just what you have to set that equation equal to. This one was only 2 points, which I thought was crazy because I thought this one was kind of hard to think to reason. It wasn't hard to solve once you got it set up, but I thought it was kind of hard to reason through first. But this is saying from K, and remember you already found that K, right? But from K to 2.416, then it is 14.47. So if you do top minus bottom, but this time I'm looking at a different area. This time B is not on top, A is on top, right? Because they swap where they intersect. Does that make sense to you guys? Okay, if I look back at this graph, instead of going from 0 to K, this time I'm going from K to 2.416. So this time it's A minus B instead of B minus A. My top and bottom switch places. So it's telling you that this area is equal to 14.470, right? You got a point. Oh. So you split it up. For some reason, you got a point for this piece. For K to 2.416, A of t dt. And then knowing, let's see, I did mine a little differently than they did. I did mine very differently than they did.
What if we did?
No, I got it right, but my way makes more sense to me. Bless you. I think you get both points for that because what you did eventually, you did find it. Yeah. I'll show you. This is what I did. To me, bless you, this makes sense because I just split my integral up, set it equal, and then I already knew what this was from a previous part of the problem. And then I could just solve for this one. Well, where else did I get that? Oh, well, my calculator, because I know what K is. And it was a calculator problem. Well, if you subtract this, it becomes negative 30, and this is negative, so I just dropped both negatives.
So we only got one for showing that the interval.
Let me show you what they did. It might make more sense to y'all than it did to me. There's part C for them.
A is the same thing we used right before.
They will never redefine a variable on you throughout a problem like that. Right. Right. That's why I said this one was just crazy. So as long as somewhere on there you had defined that integral as 44.49 whatever, you got a point, which I did. I just kind of went around to do it. And then an answer. This one was, C to me was, I thought the calculator section on here was, I thought the non-calculator was fairly easy, but I thought the calculator one was a little convoluted.
Someone's trying to get in. We can't do calculus anymore. What is that gonna do? What does it see us? They can see us. I hate to break it to you, Mrs. G, but they're gonna see us.
They're Logan's high, they can't see. Alright, I can see it.
Okay. How did I get 48.3? So
They can see our schedule. Put your calendar on.
K goes from 18.286. Where did I get that? I'm going. Didn't I already find that or something? Okay. Why did I add it to it though? Because it wants to know how much water is, that's like my initial condition. That's like my first part. I had to add it back in there. So that's my, it says all together. So that's my from 0 to K and then from K. That's what it is. Okay, part D. During, so part D asked me the rate, let's see, is the difference increasing or decreasing? So what I'm talking about is the derivative positive or negative? I can subtract derivatives very easily. So I do the derivative at 3.5, the derivative at 3.5 for A, subtract them, and I find that it's negative. So if you subtracted and showed that it was less than 0, you got a point, and then you got a point for just saying that it was decreasing. It doesn't say justify, it just says show the work that leads to your answer.
I should have just guessed.
You should have. Always do, yeah.
So if I did that, but I did the normal equation, but then I did my explanation based on I found the wrong thing.
No, I don't think so because you. Almost, but good try.
If I were to put
Sometimes if you have two different things, you'll get some partial points for something. I would say if it's just a 50-50 shot, pick one and go with it. Just write. Write some random stuff and then at least. All right, number 3. Y'all got it? Nope. Because it says show the work that leads to your answer. It does not say justify your answer or explain your answer. All right, number 3. Now we get to the good stuff. This is the stuff I feel better about. No? Average rate of change. Did anybody in here get this one, part A? Somebody did. I think one person did. So, average rate of change from -5 to 5. So, average rate of change, y'all, is slope. So I'm gonna find, remember, look, f is g prime. So I'm looking at the derivative, right? I don't. So if I want to know average rate of change of g, I have to find 5 at g. Well, they give me an equation for that. So g of 5, I felt like this was a lot of work for, oh, this one was a 3-point. So here, from 1 to 5, I go through, well, from 1 to 5 on here, I've got a triangle and a rectangle. 100%. If you ever see shapes like this, you're going to have, and you never found the area under the shapes, if it's a disjointed graph like this where it's always going to be, you're going to have to find the area under which shapes. If you don't ever do that, then you haven't answered one of the questions correctly. And then, of course, g of -5. So I went through the same thing. I had to swap my bounds and do a negative. This one was the harder of the two because from -5 to 1, I've got a triangle. Then, look, this is a quarter of a circle. So it's 1/4 pi r squared. And then I've got this little bitty triangle over here because it goes to, oh, right here. It goes to 1. Yes. So it's triangle, quarter circle, triangle. All right. Then you have to do slope formula. So that's where I came up here because I was out of room. y2 minus y1, that's my top, over x2 minus x1, that's my bottom. 7 plus pi minus 12. You wouldn't have had to simplify. You could have left it at this point right here, but you got 1 point for the difference quotient, which doesn't make any sense to me because this is the difference quotient, and then 2 points for the answer. So you didn't get any, golly gee, you didn't get any points for the work in between, which was crazy. You would lock me out there. No, I would not let you go first. What? Yes, that's your final answer. This is y, and this is y. So it's this one minus this one. Part B, you can see that if you're still copying part A. Part B is instantaneous rate of change. Remember, the graph is the derivative. If you realize that, you were just looking for the point. I know, but you didn't. You put f prime of 3 equals d and e. I don't know. Where did that come from? What? Huh? The graph was the derivative. Because if you take the derivative of both sides, you end up with g prime of x equals f of x. This is f of x. So f of x and g prime of x are the same thing. What? Corner, this is the derivative. If that was the graph of the function, it would be d and e. But since it's the graph of the derivative, you just take that value. You do what you want to do on that one. I would rather you grade yourself harder than not. On what open intervals? On what open intervals is the graph of g concave up? I'm sure you are surprised to know that I did a sign analysis. It was just the point on the graph. It was just 4. 1 point. This was 2 points, and it was just, listen, it was just the intervals with the justification. There was no in between. You got it or you didn't. 2 points. you had to understand that if you were looking at the graph, that was the derivative. So you're looking for the second derivative, you're looking at the first derivative of the graph. I have to write this every time to keep myself straight on what it is I'm looking at. They didn't say integrate the function there.
No, it was like when
That's the way they are going to define it. Define it. Know that if you see that, that means you're looking at the derivative. Be used to that notation because that's what they will use. What? Because it's a constant.
So it's a straight line.
So it's a straight line, yeah. So it was neither concave up or down. If the derivative is a constant, that means it was linear to start with, which means it just didn't have any concavity there. So where is it concave up? So I looked at where my first derivative was 0. Where is a first derivative 0? I got my endpoints, but where is a derivative? Right. So I'm looking at maxes and mins on here is what I'm looking at. And then I'm judging by, is it increasing or decreasing at those points? So I did my little sign analysis, but remember, that's not enough for your justification points. You have to give a written explanation. So I said because the derivative is equal to f of x, and the function is increasing on these intervals, that's why that is the concavity's up. Part D, I did way too much. By the way, I X'd out. If you cross anything out, they don't score it. They don't even look at it. So feel free to cross anything out. As you can see, I thought this was an EVT question. I did not read through it carefully enough. EVT would be,
Was that bracket with
parentheses. I thought I had to test the endpoints as well. I did not because they weren't asking for absolutes. They were just asking for, so all I really needed was a sign analysis, right? I need to know where, because it's asking for maximums and minimums. So I need to know where my graph is 0, because my graph is my derivative. And then it was below the axis, above the axis. And so I know that I have a local minimum at 1 because the derivative changes from negative to positive. Even though t equals -2 is critical because the derivative is 0, it's not a max or min because it doesn't change signs. And they did ask me for critical points and not just maxes and min. So you had to define both, and then you had to give the justification. So because the derivative equals 0 there. Yeah, because this is the derivative. It equals 0, but it bounces back down. So it stays negative, negative, positive. It's going to be on the screen as my understanding, and then you'll just have to write on the booklet. This is the first year they've done it like this. It is. I agree. It's going to be harder for y'all to do, too. I don't know. All right, this one was actually worth 3 points. Okay. If you considered where the derivative equals 0, which means -2 and 1. So if you have both those somewhere on there, you got a point. If you define -2 and 1 as critical points, you got a point. And if you have your answers with justifications, you've got a point.
What if we define that as critical points but didn't?
A point. I didn't give you a point? Yeah. Check over carefully, because yes. So 1 point, let me show you their breakdown. Number 4. Y'all, what the heck? Okay. Clearly, a lot of us forgot how to do this one. All right.
I've got the same answer.
This is MRAM, but it told me that there are 3 subintervals. It just FRQ adds point for point on your composite. Okay, so this says MRAM with 3 subintervals. So if I go from 0 to 6, that means every 2 is going to be an interval. It helps me to draw them on here. Well, they do this way because here's your midpoint. Here's your midpoint. Here's your midpoint. Three rectangles. If I go from 0 to 6 with 3 rectangles, 6 minus 0 is 6 divided by 3 is 2. So my my intervals go widths of 2, from 0 to 2, 2 to 4, 4 to 6. Because it says 3 subintervals, okay? So since it says, you can't see? Since y'all did all kinds of stuff here. Since it's 3 subintervals, this is why it was. And notice this was confusing too, because this was the derivative here, okay? All right. The width is 2 each time. So I've got a rectangle of width 2. The first midpoint is 3.5. This rectangle is width 2, midpoint 0.8. This rectangle is width 2, midpoint 5.8. You got 1 point for the midpoint sum. Okay, so when you did this, you get 20.2, right? But that's not the answer. And that's not the answer because you get 1 point for the midpoint sum, yes. Look at what it asked me to find. Whenever I do this, I'm finding the area under the curve from 0 to 6, okay? You had to use the fundamental theorem of calculus here. So the integral from 0 to 6 of the derivative would be f of 6 minus f of 0. It's the fundamental theorem. Okay, I plugged in. You are being a little aggravating about that. What? How do I know what? Yes, yes. So, listen, they gave me f of 0. They're asking me for f of 6. I had the integral of a derivative, so I could do that by antiderivative top minus bottom. So you got 1 point for the midpoint sum, 1 point for using the fundamental theorem, and 1 point for the answer. I know. I won't lie, I got here and I stopped for a second and I went back and read it, and that's why I went back and circled f of 6, because I was like, wait, something's not adding up. That's not f of 6. I do it before I look at the answer sheet. I'll show you the ones I missed. I'm honest. Speaking of, part B. I missed part B completely. No, if I miss it completely, I start and I erase what I had and put the right thing.
It just said, so you had to answer yes or no.
No. What? Determine whether the actual value of f of 6 could be 70. Explain your reasoning. Okay, so don't look at mine. Let me show you theirs. No, but it's not. I was trying to interpret. Let me just show you there. Don't look at that yet. Don't look at that yet. Part B. The derivative is less than 7. From 0 to 6, I don't know why they're multiplying by 7. They're getting 42. I didn't either. And I tried to make sense of what they did, and but I haven't had a chance to go back and look it up for y'all. So I don't know. I was so frustrated with this one. I probably was like, I don't like. I didn't. I got no points for this one. I looked for integral bound, so I probably looked for this. And then if you said it could not be, and I thought you knew what you were talking about, you didn't do any of that.
Miss McGee.
What?
Go back to the answer.
Hold on, ask Kaylin what she just said about our neighborhood.
What neighborhood?
What did you say? I told you.
The whole neighborhood. It went out at like 2. I couldn't finish my movie.
You were laughing.
Okay. I didn't argue with you.
I know, I was just telling you.
I know. I didn't tell him he was lying
I was
either.
complaining. I was complaining because I couldn't respond to anyone.
It's making you look a little guilty right now that I'm like, okay, Logan, that's fine. And you're like, no. Seriously.
I mean, you definitely had like a hot spot. You're like.
Oh, he definitely did.
I use my phone spot.
Didn't work.
I mean, it worked.
All right, part C, we got the boogie. Kenzie. All right, if we evaluate, oh, look. Yes, I did. Yeah. It's another, I'll go back in just a second, hold on. It's another fundamental theorem. Antiderivative of top, antiderivative of bottom, and you get the answer. This was a 2-pointer. 1 point. Well, if you do the integral of the second derivative, that gives you the first derivative. It's going backwards. Yes, the derivative at 4 and the derivative at 2. Oh, give yourself a point. 1 point for the fundamental theorem for subtracting, and 1 point for that's probably fine. Give yourself 2 points. All right. I was so proud of the next one. What? What's that mean? Oh, okay. Part D. That probably means something inappropriate. Okay. Y'all were doing L'Hopital's, and I was so proud. If you plugged in 0, you found that it was 0 over 0. Remember, it has to be an indeterminate form to use L'Hopital, which is 0 over 0, and it was. So we did the derivative. This is where start getting confused. This is why I don't show you L'Hopital's until we get to the end, because this is not how you find the derivative of a fraction, right? But this is how you evaluate you use quotient rule, right? But if it's a limit and it's indeterminate, I can just do the derivative of the top, derivative of the bottom, and then plug in. And I did, and I got -8. That was a 2-pointer. 1 point for using L'Hopital's, 1 point for the answer. Because if you plugged in initially, you got 0 over 0. Yeah. All right, we're almost back on track. Number 5. Okay. 9 o'clock. One for L'Hopital's, 1 for the answer. All right. Okay, tell me when you're done. Sometimes I'm not good at people. 5 was hard?
I didn't like it because it was like, what, is the cross section like sideways?
Okay, so listen, here's the first thing. If you did not recognize which function was what, you messed up from the very beginning, okay? E to the x always looks like a growth graph. And then that, so you know that this one has, e to the x is never going to come down like that. E to the x is always going to hug an asymptote and go up like exponential growth. It says the vertical line x equals pi over 2. All right, so it says write, but do not. Write, but do not evaluate an integral expression that gives the area of R. So you got 1 point for the integrand, top minus bottom, but you also got a point for the correct limits from 0 to pi over 2. Still was 2 points. It was an easy 2 points. All right. Both of them. No.
You gave me the point.
Take the point away. Yeah, I actually did not know how to do it. I knew how to do it.
Oh my gosh, y'all. All right. Listen, guys, listen. This was a revolution problem, okay? Which means that height was your radius, okay? But this one had a hole. This was probably the most labor intensive of all the FRQs right here in this part right here, and it was worth 4 points. All right. The area of the whole thing was the top, so that's pi r squared. I find it very helpful if I write out my areas and my volumes to help me try to find these values. So the whole thing, which was the top function, as opposed to the whole, like your top and your bottom wrong.
Like in the previous one. There we go. I got the right equations, but
Well, so for this one, the integrand itself is only worth 1 point. Did you find the antiderivatives correctly? If you did the antiderivatives correctly, that's 2 points. Like this part. Oh, I did. All right, so pi integral whole minus whole. This was a little u substitution. That's why I have pi over 2 here. This one was just straight evaluate. I adjust my bounds. Yep. If you do a u substitution, your bounds have to be adjusted for the u substitution as well. They don't have to unless you. So whatever my u is, I let my u be 2x. I always write it off to the side. You plug in the bounds to here. So 2 times pi over 2 is pi. 2 times 0 is 0. No, 2x. So 2 times this and 2 times this. Bless you. Right. Right. Right.
no.
1 point for the integrand, 2 points for the antiderivatives, and 1 point for the answer. Huh? Let me show you. I'll also show you how they did it.
I don't understand why people
There's their solutions if you want to see what they did. No, that's mine. All right, part C. That one was part C, 2. So region R is the base of a solid semicircle. This is where y'all messed up on this. If the base is a solid, I'm not revolving. That means my height is my diameter, not my radius anymore. I'm not circling it around. Instead, that base hold on, I'll look. This, and that would be my radius if I'm revolving, but if that's a solid, that's my whole diameter of my circle. So to find the radius, I have to cut it in